Today I'm gonna talk about my PhD project, which is about the need for an application-aware resource management for the future cellular networks because of the rising multimedia IoT applications. There are many services in 5G. Three main categories are Enhanced Mobile Broadband, EMBB, Ultra Reliable Low Latency, URLC, Massive Machine Type Communication, or MMTC. Each of them has different requirements, and so we cannot behave them in the same way. For example, EMBB, which is the next generation of the mobile applications we use these days, requires a high data rate. Video streaming, cloud games are a few examples of this category. On the other hand, URLC use cases generate short packets, but they need them to be sent as soon as possible and in a highly reliable path. For example, autonomous cars, remote surgery, and haptics. The last category of services is MMTC, which are IoT devices. They also generate short packets, but periodically, and so congest the network with a high amount of signaling. Sensor networks, smart cities, smart buildings are a few examples. Multimedia also pours fuel on this fire. They are delay sensitive and mostly require high bandwidths, but they also have categories that could be totally different from each other. Stationary or mobile, generating low or high downlink, uplink data volume. So, this amount of heterogeneous traffic can be a problem for future cellular networks. To explore the idea of differences between services, we started with the high-level data analysis of connected cars as a use case of multimedia IoT. We put devices of a UK mobile network operator into three categories: connected cars, smartphones, and other IoT devices, and then studied their properties. The first observation is that cars support new radio technology later than smartphones, but sooner than other IoT devices. Still, discontinuing 2G will affect connected cars as significantly as on other IoT devices. In the next round, we compare the number of radio signaling events per user of each device type. Still, smartphones are the most active devices on the network, but connected cars also generated higher number of signals than other IoT, which can be explained by their high mobility. So far, we conclude that verticals of IoT devices have different characteristics, but then we decided to study cars of different brands to see if they behave in the same way. As an example, you can see in the picture on the right, cars of each brand generate different amounts of signaling. All of these analyses show that we have varied use cases and also even varied types for a use case based on the services they provide. So, a new aspect proposed in 5G era to provide services their requirements, namely network slices. Network slices are the logical networks created on the same shared physical network infrastructure based on the service demands. In NS, resources should be allocated based on the service demands, but also the configuration of the network algorithm might be changed. For example, for URLC that we need low latency, we should change the scheduling or admission control to offer them their required latency, or some other functions would not be needed. For example, again for URLC, segmentation might be discarded because they generate small and fixed size packets. In my PhD project, I have two main challenges. First, recognizing services and their requirements, URLC in particular. These days, most of the packets are sent in the network as best effort traffic without any guarantees. So the first issue here is how to differentiate packets of different services and know their demands. In this stage, I'm continuing the data analysis toward the low level to obtain more detailed knowledge about multimedia IoT services. I built a learning method to discover traffic patterns and demands of the services. Then I'll design network algorithm and configurations according to the URLC characteristics and needs. It will be model-free learning-based network slicing that meets the requirements of services and also maximizing resource utilization. Thank you for your attention, and I will be happy to hear your questions and recommendations.